Welcome to this video, Thales theorem. Here is Thales. He is a Greek mathematician who founded geometry, physics, and astronomy. He predicted the solar eclipse. He was the first to research scientific philosophy. He gave many theories in geometry. He proposed the Thales theorem. What is Thales? Now it's time to watch this short video about the story of Thales.
Thales of Miletus was a Greek philosopher born in about 623 BC. He was one of the so-called seven sages of ancient Greece, and his interests ranged across philosophy, history, science, mathematics, engineering, geography, and politics. Instead of resorting to supernatural beliefs, Thales put forward practical, rational explanations for events that he observed in nature. He founded the Malaysian School of Natural Philosophy and is the first person we know of for sure in Western civilization who had a scientific approach to answering questions. Thales liked to travel. On one of his journeys he went to Egypt to see the pyramids. These had been built at least 2,000 years before Thales was born, so they were an ancient tourist attraction even by his time. Like many tourists, Thales wanted to know the height of the Great Pyramid. He couldn't find anyone who knew the answer, so he figured it out for himself. So how could you measure the height of the Great Pyramid in the 6th century BC? Researchers think that Thales did it using a method that involved similar triangles. These are triangles with the same shape but different size. Their corresponding angles are the same, and although their corresponding sides are different in length, the proportion of the sides are the same. Now let's look how Thales may have carried out his measurement. One possibility to find the pyramid's height is that he pushed a stick partway into the ground so that it stood straight up. He carefully measured the stick's height and the length of the stick's shadow. Then he measured the Great Pyramid's shadow. He'd formed similar triangles because their corresponding angles were the same. Therefore, the ratio of the pyramid's height to the stick's height was equal to the ratio of half the length of the pyramid's base plus the length of the pyramid's shadow to the length of the stick's shadow. After a simple calculation, he found the pyramid's height to be in modern units 146.5 meters or 481 feet, which at the time would have been correct. Today, the Great Pyramid is only 138.8 meters or 455 feet high because of erosion. Later, the philosopher Plutarch wrote about this incident. Although the king of Egypt admired Thales for many things, he particularly liked the way in which he measured the height of the pyramid without any trouble and instrument. Thales set up a stick at the tip of the shadow cast by the pyramid, and thus having two triangles by the sun's rays, he showed that the ratio of the pyramid to the stick is the same as the ratio of the respective shadows. So, you don't need an incredibly long tape measure to find the height of very tall things, just a stick, a ruler, and a bit of ingenuity.
How to apply Thales theorem? We have ABC is a triangle, D is parallel to BC and cuts AB in M and cuts AC in M. So now we have AM over AB is equal to AN over AC. Case 1. Case 2 also, if you have extension of the segment AC and AB, also straight line D cuts their extensions proportionally. So AN over AC equal AM over AB. Other properties of Thales, we can say that AM over AB equal AN over AC equal also MN over BC. MA over MB equal AM over NC. Also AB over MB equal AC over NC. Here is an application in order to find X in each case. We are going to find it by applying Thales. So first of all, we have to recognize the ratios equal in order to find the value of X. 1. DE is parallel to AC. So according to Thales theorem, BD over DA is equal to BE over EC. So by cross multiplication, X will be equal to 9. In the same manner, we can solve the other figures. So pause the video and try to solve them alone. So now you can check your work and check if you applied the Thales theorem correctly and you find X in this way. Now we have an application to show that MO over MA equal AO over AW. First of all, let's take triangle AOH. In triangle AOH, we have MN is parallel to AH. So according to Thales theorem, we have MO over MA is equal to NO over NH. Now let's go to triangle OWH. We have also AN parallel to WH. So we have AN is parallel to WH. It means that we can apply Thales theorem. AO over AW is equal to NO over NH. So by substitution, these three ratios are equal. The converse of Thales theorems: if M is a point of AB and N is a point of IC such that the two ratios are equal, then the two lines are parallel. Look at this application. Show that AC is parallel to BD. So first let's find ratio OA over OB, which is equal to 4 over 5. Now let's find OC over OD. It's also 4 over 5. This means that OA over OB it's equal to OC over OD. So two ratios are equal. Then we can say that AC and BD are parallel by the converse of Thales theorem. Now the enlargement of a figure. How to enlarge a figure? O at the center and vector K. Let's draw first OA, OB, OC. And now, for example, let's take a K equal to 2. So we have to locate A prime so that OA prime it's double OA. Now let's find OC prime such that it's double OC. And also OB prime. So as a result, we join A prime, B prime, C prime. You will get a triangle A prime, B prime, C prime, which is the enlargement of ABC by scale factor 2. And now in order to reduce it, the only difference between them is the scale factor should be less than 1. Look at this example. What is the scale factor of the enlargement of PARC, which is the enlargement of MINE with center O? In order to know it, you have to find the ratio of the new one over the old one. Let's take PA and MI. OP over OM equal OA over OI equal PA over MI, which is 5 over 3. Since 5 over 3 is greater than 1, so we have enlargement. So the scale factor is 5 over 3. In order to find the other length, we can use the ratios to find them. We get NI equal 6 and EN equal 1.2.